All right, welcome everyone. Welcome to this June GDG Cloud Montreal event. We're going to talk about where we're going to store our data in Google Cloud. I'm just going to go through a few housekeeping things, and also we'll go through a little TLDR of Google Cloud News before I pass it on to Rogerio, who's going to cover the where to store your data in GCP. So, well, I just mentioned that, so we can skip that over quickly. So, of course, today's speakers, I'm going to do the TLDR piece. Rogerio will present himself properly. So I'm from SARA, so Stacy Verano, for those who don't know me, senior pre-sales cloud engineer. And I have Rogerio Oliveira also with me, from like a CE also, like myself, but on the Google side. All right, so a few questions. If you have questions like during the event, we may do like Q&A during if there's any question popping up. So I'll be moderating the chat section, also the Q&A session. So if you go at the top right inside the Bevy window, you have like the chat, and there's like general, there's Q&A and DMs. So if you go in Q&A, you can ask there, and we can put the answers there also. If we have a limited group, can just like drop it directly in general, and I'll moderate, and I'll be able to pass the information to Rogerio, because while we present on Bevy, sometimes it's hard to see the questions popping up, so I'll be able to pass that information along to him. Yeah, so I have a few slides, nothing major. It's been a while, so I was usually doing that like more regularly. But there's a few things that happened, like with the security, the security summit that happened at Google. Of course, like I/O wasn't there, Gen AI everywhere. So kind of sum that up into just a few slides, and all those slides are going to have links everywhere, and of course they're super long links. So what I'll do is that when we're done, like on the event page, under the sections regarding the GCP News TLDR, you'll actually have the links pasted in there, so that way you can follow them if that's of interest to you. All right, so some of the GCP News TLDR, there's a lot in there. So we have of course, like there was no way to not talk about generative AI. Like there's no way since I/O. So there's a lot of resources coming on from the Google side. So it's not just like the Google Cloud side of things, but also like Google in general. So there is the Vertex AI Studio that you can play with within GCP, allow you to like test your prompts, test interaction with the Gen AI engine, but within Vertex AI Studio. So that way you're also able to keep that information within GCP. Kind of segue in security on that one. There's also like a cloud skill boost that's been posted. You probably saw a lot of people with those badges on LinkedIn, completion badge. So there is a track you can follow. At the time, it was now at 9 activities, and it keeps on growing. So it just like helps you cover. It's not just like intro stuff. You'll go to like mid-level to more complex also type of activities. So it's great to get you a feel of how actually Gen AI works. Get you like the kind of like the basic information you need to kind of understand the ecosystem and what's actually going on there. So it's great activities. And of course there's Bard that was announced. And of course, well, if you're in Canada, want to use Bard, you may feel frustrated, but VPN is your friend. So if you really want to test it out, just VPN to the US and go and hit bard.google.com, and you can actually get things going and see the way you can interact with it, and maybe help you like summarize some text or things that we can do with generative AI in regards to more of a just like raw conversational AI, sorry, and go in details of like how can I use this to maybe make my work a bit easier. Just continuing on the news, but more like focusing more like on the GCP side of things. If you're of course, like, well, everybody's trying to go serverless, or there's a lot of people leveraging Kubernetes also directly, but they're still like on the compute side of things, or within Compute Engine. There are always innovations. So there are there's the fleet. The VM Fleet Health within Compute Engine Console that's now being GA. That's something where actually, like, you have multiple VMs, and yes, if you're actually running Kubernetes, your nodes are actually compute. You can actually see the health of everything. So in terms of CPU, RAM, disk I/O utilization, into one page. Sometimes it's things that are straight in our face and we don't see it. So I thought, since it's GA, to kind of mention it. So feel free to have a look. Again, all those super long links will be put inside the event page. So feel free to have a look. There's a security command center premium pricing drop. So yes, it's not a technology thing, but it's something. Sometimes it's a barrier, like budget. So be able to leverage security command center, which is your posture management within GCP. For those who are not familiar with security command center, usually, like, initially, this was something that was at the org level. So usually come in with a bigger price tag. Now you're able to do it at the project level, which is nice. So maybe you can focus your posture management for security on your production project, and from there, you're able to just pay for the resources you're monitoring inside of that. In terms of like pricing itself, if you're using the Google Cloud Calculator, and let's say, I don't know, like, you have like five GK clusters with 2 Cloud SQL database and all that, if you put that into the Google Cloud Calculator that's online, uh, there's also the security command center at the project level now that's inside that calculator. And if you add it, it will tell you exactly at the project level how much it's going to cost you. So not a bad thing. I know it's not a technology thing; it's more a money thing, but it may be actually something that helps you, engage in leveraging some of the premium features of Security Command Center. Um, so also, like, in terms of, well, segueing into the next piece of Security Command Center, there's a new way to protect identities within Security Command Center. So it's your CSPM, so your Cloud Security Posture Management. And that little feature actually allows you to see, like, service account impersonation that may be a bit weird, or like maybe multiple failure attempt have like escalating IAM permission on an account. So this is something that was not really in Security Command Center before, but this is something now that's actually being added. So great addition. Again, the link will bring you to the more details on that feature. There's also, last time, our last event with Mr. Sanders, we talk about Cloud Deploy also. And now there's like, if you actually want to do canary deployment with it, Cloud Deploy, great article that actually telling you how to do that. So have a look. Um, so uh, continuing in monitoring, so there's in Cloud Monitor right now. There are like better tools for uptime checks and alerts. So a little bit of addition. So new dashboards, you'll see new preset dashboards. So, and have a look. In terms of connectivity, there's cross-cloud interconnect. So basically, like I said, like, it's networking magic. Like, if you have it on-prem, or if you have like right now, you may have an interconnect that, well, would love to have like that type of bandwidth in an easy way between, cloud A and cloud B. So you're actually now able to do that with cross-cloud interconnect, which is a great way to, like, set up a pipe properly, which is not like a cloud VPN 3 gig limitation, but actually have proper pipes between your cloud providers. So that's something that's now in GCP. So that's great. I've been talking about cost, and like now the interconnect now as a cost also. In past engagement, we've talked about FinOps at one point with another Googler from Montreal. And actually, there's a great FinOps roadmap that you're able to follow, and it's written on the Google website. So just put the link in there, because everything we're doing, it's always nice to actually get some control over cost. It's not that we don't want to innovate within the clouds, that we want to be able to innovate within a budget that makes sense. And getting visibility on the spend actually makes total sense. So have a look. Next one, well, going back into security, there's a chronicle that's been added, the threat detection and investigation and response, or the TDIR option, which makes it like when you're in Chronicle, you're able to ingest stuff straight from your CSPM, so Security Command Center Premium, and then from there you're able to get better intelligence, which is you're able actually to do the response piece, which is usually can you run this playbook when this happens on my threat detection. It's now been like made super easier, so that's something that's super nice to look at. So feel free to have a look if you're looking at leveraging Chronicle for your SIM. That's something that definitely, it's a quick read. It's probably like a 5-minute thing. So have a look. So again, like, well, there's another one in Security Command Center. There's a lot because of the Security Summit. Like there was a lot coming in. So now there's something in Security Command Center Premium that's called Attack Path Simulation. So if you are familiar with Security Command Center, if you go in your findings, you'll see everything that's happening. But now you'll have a new column, which is a score, which is like how severe is this? And if you click on it, you can actually, let's say I have a public bucket with a JSON file in it, which is like the worst thing I could do. You can actually see the attack vector that somebody would take to get this information out of you because it's not properly secured. So it's giving you visual and on the threats that are exposed to you in your findings, which is a great addition. This is coming from the acquisition of ForceCD, not ForceCD, which was another tool that was used within GCP like a while ago. It's ForceCD. So it's been merged within Security Command Center, those features and Premium, and so a great addition. And last but not least, now we have, again, coming from the Security Summit, you have the Secure Web Proxy for egress traffic protection. So right now say, oh yeah, well, like nothing has a public IP, so I have a cloud NAT, I can define some rules and all that, but I need to go more granular. There was not really like any like baked in option, but now you actually have that through Secure Web Proxy for egress traffic. So that way you can define and really isolate like who can do what when it comes to outside traffic, which is a great addition, again, giving you more control and security in GCP. And Rogerio, I'm going to call you out because I'm getting to my last slide. Of course, don't forget next 23. If you're lucky, if you're going to San Francisco, all good. If you can't, but would still love to interact with, let's say like a talk that's happening there. I know they have. I think it's called like digital passes that are coming, and those digital passes, which are not free, but still at a lower cost, will allow you to actually be able to interact with sessions like if you add a microphone and being on site to ask questions. So keep a lookout, and we're gonna try to use this as the base for our talk in September, since this is at the end of August, and get a recap per topics like AI, ML, compute, serverless, and get back to you with a nice Q3 event. Hopefully, maybe at Google Montreal. Never know. All right, so now we're ready for, that's not the official title, of course, but it's like, dude, where do I store my data in GCP? So I'll pass it on. I'll stop sharing, but I'll pass it on to Rogerio, which is Cloud Engineer Data Platform at Google. And from the slideshow at the beginning, the rolling slideshow, you saw his background, just putting in there also for people who may skip the beginning of the recording. So they have the TLDR on Rogerio at Google, and I'll stop sharing, and Google, stop sharing Google. All right, here we go. And Rogerio, the floor is yours.
Hi, can you hear me okay?
Perfectly.
Awesome. By the way, I love that slide. I'm going to steal it from you and put it in my deck next time. I really enjoyed it.
No problem. My pleasure.
So first of all, my name is Rogerio Oliveira. I am a data management specialist with Google. I've been here for 3.5 years now. Can't believe it. Anyway, I come with a lot of experience in data management behind the scenes. Actually, I've spent quite a few years working for banks in Canada and as well as Oracle Canada. So I know a lot about database management from a point. So let me start sharing my screen now. By the way, Stacy mentioned this, and I just wanted to reiterate, I won't be able to see any questions popping up because I'm supposed to share my entire screen, but feel free to post your questions, and I'll interrupt from time to time and ask if there's any questions on the chat. All right, so let me try to do this. So Stacy, I'm supposed to share my entire screen, right?
Yes, if not, it's gonna. We found out that sometimes when we love to share a tab, but it kind of makes it super small when you share it.
Okay.
And that's the platform thing. So.
All right, so there's going to be a little bit of mirroring for the beginning, but I'll minimize my presentation screen in a moment and should be corrected, hopefully. How does it look?
Perfect and in big, which is perfect.
All right, awesome.
Awesome.
Yeah. So thank you for the opportunity, Stacy. By the way, that speaking at meetups and events like this one is one of the favorite aspects of my job. I really enjoy talking to folks directly. It's something I always enjoyed. So the topic today is to talk about where to store my data on the Google Cloud, on GCP. And the rationale behind this particular presentation is because I've been talking exactly on that topic for with several customers for a few years now, and that is something that always pops up, right? So we have a lot of database management systems on GCP now. And the question is, okay, which one should I use for my application? Which one should I use for my workload? And it's a fair question, mainly because who has the time to review everything or all the options out there and come up with the best solution by themselves, right? So that's why we're here. That's why us custom engineers and solution architects and the specialists are here to help you out, make the best decision for your application. So I like to start with this slide here just because it summarizes pretty much everything we're going to discuss. So as you can see, we have today 3, 6, 7, 8 different database solutions available on GCP. Everything from relational to non-relational, as well as traditional and cloud-native solutions. Now, speaking about data storage is just one piece of the puzzle, right? We also need to speak about how do I move my data, right? So you may have already a database running on-premise today or on a different cloud provider, and you're not happy and you wanted to minimize workloads, minimize the operational overhead rather, and you want to move to GCP. So how do I do that? So we're going to talk about 2 options that we have on GCP as well. And the other thing is sometimes, occasionally, you may have a specific workload for which we don't have the best fit for it. So for example, you may have a workload that requires something like a GraphDB, such as a Neo4j. Currently, we don't have that solution. However, we do have an extensive partner ecosystem, and SADA being one of them. Thank you, SADA. And we do have offerings on GCP that will allow customers to simply deploy their specific solutions directly from the GCP marketplace. And we'll talk about that as well at the end of the presentation very briefly. All right, so let's start talking about relational options. That's typically the most kind of popular offerings we have on GCP. And specifically, Cloud SQL is perhaps the most popular role, right? So Cloud SQL essentially is a fully managed relational database solution in a cloud. So that basically means very little operational overhead. It tends to be falling on the traditional side just because we leverage existing database engines such as Postgres, SQL Server, and MySQL databases. So from that perspective, there's nothing really spectacular about those. We're just taking those databases and making them available in the cloud in a fully managed fashion. Now, yeah, from a feature standpoint, it may be and look like exactly like on-premise deployments of those databases. However, that's where the similarities end, right? So things on the cloud, specifically for Cloud SQL, are a lot easier to manage comparing to your on-premise solution. So, for example, one of the things that it's very common for any workload is I need to set up HA and DR, so high availability and disaster recovery for data protection. So doing this on premise tends to be very convoluted. You have to basically mess around with the underlying database technologies for those, which can be time consuming to set up, prone to errors. The monitoring is another aspect that you have to be on top of it to make sure things do not break. The last thing you want is to find out that your replica is not working as it intended at the worst time possible when you need it. So I'm going to draw your attention to the screenshot on the right side. As you can see on the bottom, there is one option there, zonal availability. So you simply pick between single zone or multiple zones. And that's as simple as it can be to set up HA. Choose the second option, which is marked on the slide. You are going to create a replica of your existing database in a different zone in the same region. So basically, let me just translate that. A zone is simply a separate region on GCP that's isolated from the other zones. So if there's a failure in one zone, that doesn't mean you're going to have a failure in another zone. So that covers situations where you may lose your instance, or it crashed, or your zone crashed, or something like this. The best thing about it is that the replication between the two zones is synchronous. So that basically means you don't have any data loss. And the other thing is the failover is automatic. So you don't have to do anything. So if something happens to your instance, it crashes, it simply fails over to the surviving instance in real time. Now, the other thing is the endpoint, the IP address that you use to connect to your primary instance does not change. So that moves over to the surviving instance as well. So from a client standpoint, your clients, the only thing they're going to experience is a short downtime while the connectivity is reestablished. That's pretty much it. Now, that covers a situation where you have a failure with your instance or a zone in the same region, in the same data center. What if you have a failure in the entire data center, right? So a region fails altogether. In that case, you also need to set up DR. And the process to set up DR is as simple as the HA process. So it's just a matter of selecting an option on GCP console. And that essentially enables asynchronous replication between two data centers, or it could be in the same data center as well, but typically you do it in different data centers or different regions. So it could have been something like, for example, you have your primary database running in Montreal, and then you have your standby database running in Toronto. If something happens to Montreal, you can still fail over to Toronto. Now, the replication is asynchronous, right? So there is a potential for a data loss, but that's the price you have to pay for the long distances involved. It's just physically not possible to have a synchronous replication between data centers, separate regions altogether, because of the replication lag that exists between the two environments, or the network lag. Now, being a fully managed environment, you have fully managed backups. All you have to do is define when you want the backups to run and how long you want to keep them for, so the retention period. Downtime for maintenance is under 2 minutes. This is something that I always get asked. How is that possible, right? So if we're doing a planned maintenance, we're typically applying bug fixes, security patches, both on the VM level, underlying VM level that you don't see, which is basically abstracted away from you, and database engine. So how is that possible? That happens in 2 minutes. Every time as a DBA, when I had to apply patching to an existing instance, it would take forever, right? So not only do you have to test the patch, but you also have to test the patching process as well as do the patching process. So that takes time. And the reason why it's so fast is because we basically build an instance identical to yours before the actual cutover date, before the actual maintenance date, apply all the patches to it on the binaries. The only thing we don't do is touch your data. So on the actual date, when the maintenance is supposed to take place, all that's left to do is to detach the disks, the data disks, from your existing instance and attach to the new instance that's been already patched. So that's why the downtime is so short, 2 minutes only. And realistically speaking, it's even less than that. So that's a great advantage comparing to on-premise deployments, because you just don't have to do any of that. You don't have to do the testing. You don't have to worry about backout strategies. You don't have to worry about the actual patching itself. And of course, like pretty much everything else on GCP, you can scale up and down as needed, which is a great feature as well, right? So you don't have to get it right from the beginning. So there are obviously there's some recommendations and some guidelines in terms of how you should start, your starting point, in terms of sizing, CPU, memory, etc. But you don't have to get it 100% right. The important thing is to keep an eye on monitoring. There's so many metrics you can use for that, in alerts and etc. And if you see that you're getting close to a specific threshold, you can simply bring down the instance, increase capacity or resource allocation, and bring it back up. So it's as simple as that. And similarly, if you realize, okay, I have an oversized instance for my given workload, and I wanted to save costs, you can bring down the instance, scale down, and bring it back up. So that will be more difficult to be done on premise, because it's dependent on how much resources you have available on the underlying machine or underlying VM. In the case of GCP, that's not something you have to worry about it. As long as you're within the maximum size of an instance, which is 96 CPUs and over 700 gigabytes of memory, you're absolutely fine. You can scale up and down as needed. So the important question is, when should I use it for my specific application? So essentially, anytime you need a relational database solution for applications, which tends to be the vast majority of the applications out there, right? So relational databases exist for a reason. They have typically very high data integrity, atomicity, isolation, all the ACID properties that you know, as well as strong consistency, which is something you don't typically see with NoSQL databases, which we'll talk about it in a moment or so. Now, the only thing is, relational databases are great, but they are difficult to manage. So Cloud SQL is perfect for when you need a relational database solution, but you don't want to manage all the bits and pieces that will go with it. Now, one constraint, or I should say one specific characteristics of Cloud SQL, is that it supports 3 different engines, and those are the only engines that we support today. There are different versions that we support. We will have to check the documentation to see which particular version you are looking for, if it's supported. But we pretty much try to support as many versions as possible, as long as the version is supported by the underlying vendor or in underlying community. In the case of Postgres, we try to keep it as current as possible. In the other use cases, when you need elasticity, right? So you don't know how much resource how much resource allocation you're going to need initially. So that is sometimes tricky to get it right. So that goes to the point I mentioned a few minutes ago, which is scale up and down as needed. So you don't have to get it right. So you need that kind of ability to go up and to scale up and down as needed. And of course, there's another important use case, which is when I wanted to modernize legacy relational database solutions. For example, one typical use case, one typical discussion or conversations I have with customers is when they running Oracle databases, and they wanted to modernize that, maybe because they're paying too much money in terms of licensing, or because it requires too much resource allocation, or the management itself is very difficult. So in that case, usually customers wanted to have a conversation about how to modernize that to something like Postgres. So Cloud SQL is a perfect solution for that, because it essentially allows you to move from an existing database like Oracle, which is difficult to manage, expensive, to something that's license-free, like Postgres, and easy to manage. Now, there are a few situations that you may not want to use it. The first one is if you have to guarantee an SLA with your clients higher than 3 nines and a half, Cloud SQL might not be a good choice. And the reason for that is because that's what we guarantee by contract. Now, I need to qualify this, right? So when you say 99.95, that's not what you typically get. You typically get much more than that. This is what we guarantee by contract. So meaning if we violate that SLA, you are financially compensated. But depending on the contractual reasons or contractual obligations you may have with the clients, you may need to have a guaranteed SLA that's higher than that. Then we'll talk about other options that can support a higher SLA. The other thing is Cloud SQL is very elastic from a CPU memory standpoint, as well from a storage capacity standpoint. But there is one important thing you have to keep in mind in terms of how much throughput you're going to have on the Cloud SQL. And I'm talking about I/O throughput. And the limit tends to be around 1,200 megabytes per second for reads and 400 megabytes per second for writes. So beyond that, we won't be able to scale Cloud SQL any longer. And in that case, we would have to look into a different database engine. The other situation where you may want something else rather than Cloud SQL is in situations where you need horizontal scalability. So it's horizontal scalability essentially is the ability to scale a cluster of nodes or adding more nodes to your cluster to scale up from that perspective, right? So rather than simply adding additional resources, which is vertical scalability, you want to add more nodes and you want them to work in parallel for you. So Cloud SQL does support read replicas, but those read replicas are individual, so they are separate. Each one has a separate endpoint. You can create as many as 20 read replicas, but each one will have a separate endpoint. So they won't have a single kind of load balancer capability that would allow you to parallelize the workloads in between the various replicas that you have. You can do that with things such as proc SQL in case of MySQL or PG Bouncer in case of Postgres, but that's something you have to do it and manage yourself. So it's not out of the box. And there are a few features in Cloud SQL, or I should say in the database engines, so the underlying database engines that are not supported in the Cloud SQL. There are very few. There's essentially in situations where it would potentially jeopardize the stability of the environment, right? So things such as sysadmin would require sysadmin access and things like that. But generally speaking, pretty much everything you see available for one of those database engines would be also available in Cloud SQL. All right, let me pause here for a moment and see if there's any questions so far. I know I threw a lot of information right at the beginning. Stacy, do we have any questions on the chat?
Yes, actually, we have Jimmy was asking about what's the availability of HA for failover, like on multiple zones when it comes to Cloud SQL. Is it like below 99.95 or by contract you can go lower than that? Anyway.
Yeah, that's a good question. So 99.95% SLA is when a customer chooses a Cloud SQL with one HA and one DR. If you're going to have multiple cross-replication replicas, that's not going to increase the SLA that we guarantee to you, right? So the minimum we're going to need to have in order to be able to eligible to that guaranteed SLA is one HA, one DR. If you go beyond that, it's not going to make any difference from a contractual standpoint. If you go below that, then it's going to affect your SLA. In that case, we'll have to reach out to the sales team, and they'll build something customized for you based on your requirements.
Cool. All right. GB just replied, thanks for the clarification. So all good. And that was the only question. So.
All right. Awesome. All right. Oh, too much. So the next database solution I want to talk about is AlloyDB. That's the new kid on the block. It's been released in GA in December. And currently, it's not available in Canada yet. It's promised to be available in Canada by the end of this month or the end of this quarter. The end of this quarter, more specifically. So it's only about 10 days left. We should be making it GA in Canada very soon. So first of all, what is AlloyDB? AlloyDB is a Postgres engine on steroids, I should say. And what we've done is Postgres, because it's an open source engine, we forked the code for Postgres and added some enhancements that you don't see in a vanilla kind of Postgres instance. And I'll talk about those in a moment. But first of all, just like with Cloud SQL, it is a fully managed relational database solution. So just like with Cloud SQL, very little operational overhead associated with managing the instance. That's essentially where the differences will begin, right? Because other than having a fully managed environment, low ops, in a Postgres engine, there are quite a few differences between Postgres and Cloud SQL, between Cloud SQL and AlloyDB. The first one is the separation of compute and storage. And for those familiar with BigQuery, that is very similar. So what happens here is we separate compute, meaning all the VMs and all the resources associated with the VMs, from the underlying storage. And the underlying storage is actually a system that takes your data, it splits into chunks of data, and spread them across multiple underlying splits or chunks of data. So the advantage of doing that is that we have all those chunks working in parallel for you. So when you make a request to AlloyDB, you're not bound by the local storage. You have potentially a much more scalable storage system in the back end. So that allows I/O throughputs to increase significantly. That's why when you hit that limit in Cloud SQL, which involves 1,200 megabytes per second for reads and 400 megabytes per second for writes, we typically recommend AlloyDB because you don't have that limitation anymore. So that's difference number one. Difference number two is, just like with Cloud SQL, you can also create a pool of resources, read replicas, essentially. But differently than Cloud SQL, they actually exist behind a load balancer. So that basically means you have one endpoint, you can get that endpoint and give to your clients. And when they hit that endpoint, the load balancer will distribute the load across instances. And just make sure I'm clear, that's just for reads. That doesn't work for writes. If you need horizontal scalability for writes, we're going to talk about Span in a moment, which is a solution for that. For reads, for writes, in case of AlloyDB, they all go to the same instance, right? That's how Postgres maintains data integrity, by accepting writes from one instance only. But for reads, which is typically more problematic in terms of query optimization and performance optimization, you can actually distribute that across multiple instances behind the load balancer. That's managed automatically for you, by the way. You don't have to create the load balancer. You don't have to manage that. You simply create the pool, telling AlloyDB how many instances you want in that pool, and also what the size of the instances should be, which is another interesting aspect. You don't have to size those instances to your write or read and write instance. Now, for those who are familiar with Postgres, you would know that managing memory allocation, as well as vacuum management, can be a pain point, right? So memory management in Postgres is tricky because if you allocate too much memory to system, for example, as opposed to more memory to buffer cache, you might be wasting resources, right? The system may not need that much memory, and that amount of memory could have been gone to buffer cache to improve performance. And similarly, if you allocate too much, or conversely, I should say, if you allocate too much memory to buffer cache and less memory to the system, you run into a situation where the system runs out of memory and the performance is going to be affected as well. So getting that balance is very, very tricky. But that's not something you have to worry about in AlloyDB. So AlloyDB maintains the memory allocation automatically based on working conditions. So basically, the optimizer will check, okay, do I have enough memory at the moment that can be assigned to the buffer cache? I'll do so. If I can't, the system is under pressure, I'll allocate more memory to the system. So that's done automatically for you transparently. You don't have to do anything about it. The other thing is vacuum management. As I mentioned, in Postgres, if you don't allocate enough resources to vacuum management, you can run out of transaction IDs, which is a major problem, right? So essentially, your database comes to a halt. And just like with memory management, if it allocates too much resources, too many resources, you are going to be wasting resources. So you don't want that because you're paying for those resources. So that is also managed automatically for you by Postgres, the Postgres engine that we have enhanced. So the way it works is at any given time, we're going to try to give as much resources as possible to vacuum management within the limit. If there are no more resources to be allocated, what the engine is going to be is going to throttle the number of transactions that can be consumed at a time. That way you don't run out of transaction IDs. And that's done automatically. Of course, that is not the ideal scenario. When you hit that point, you probably should have already added additional resources to your system, not to vacuum management. Basically meaning you would have to have added more memory and CPU to your instance. Once the instance has more resources, you'll be able to allocate more resources to vacuum management automatically. Now, one of the greatest things about AlloyDB, in my opinion, is the fact that it can support analytical workloads as well as relational workloads. Now, Postgres, just like with any other relational database, tends to struggle a little bit with analytical workloads simply because it's not designed for that, right? It's designed for relational workloads. For one, the tables are organized by rows and columns, which is not the ideal format for analytical workloads. Now, in AlloyDB, we give you an option. Not only can you keep your tables stored as is in a relational format, but you can also create a columnar stored or columnar engine for that table. So that way, if analytical workloads are requested by your clients, the optimizer now has a choice to redirect that workloads to the columnar engine, which makes your analytical workloads much faster. Now, when should you use it? So essentially, when you need a cost-effective, horizontally scalable solution, when you need more performance than Cloud SQL, but you don't want to manage all the bits and pieces that are required to manage a relational solution. If you need a high-performance database, and usually is the preferred choice for customers looking to modernize something like Oracle, that is a perfect choice. It has the capacity, in many cases, to exceed the performance of an Oracle instance. So it really depends on the workloads, of course. That has to be sized accordingly, and that's something I do for a living. As a matter of fact, we help customers do exactly this. But AlloyDB has a much greater performance characteristics than Cloud SQL, and it's a preferred choice for high-performance databases. The other thing that's really, I wouldn't say a limitation, but it's how Postgres works. I'm talking about the standard Postgres, the vanilla Postgres engine, is beyond 32 CPUs, it won't really be able to take much advantage of additional CPUs. So it can scale up nicely up to 36 CPUs, but if you add like 96 CPUs, the engine is not going to be able to take too much advantage of that additional cores that you're adding to it. That's not a problem with AlloyDB. We have made it linearly scalable. So that basically means if you have 96 CPUs allocated to the instance is going to be able to take advantage of those 96 CPUs. Now, assuming, of course, that your workload is CPU bound, right? If your workload is not CPU bound, that additional CPU is not going to make any difference. But if you have a highly computational workload that you need to add more CPUs, you would be able to scale up as much as you can with AlloyDB, which is currently, I believe, 96 CPUs you can grow up to. And then it's going to take advantage of that. Now, when should you not use AlloyDB? So as I mentioned, it is a Postgres engine, and specifically is a Postgres 14 engine. So if you have an existing workload that's running in a different version, like MySQL, or maybe is running an older version of Postgres, you would have to migrate to Postgres 14 or upgrade it to Postgres 14, or you're going to need to find a different solution. In that case, could be Cloud SQL. So that's one important thing to keep in mind. We are working towards adding additional database engines in the future. but currently that's the only engine that we support in AlloyDB. Another important aspect to keep in mind, you remember that Cloud SQL supports 3.9.5 SLA. That's the guaranteed SLA that we provide. But that's exclusive of maintenance. So basically, maintenance is not taken into account in that number. AlloyDB, on the other hand, supports 4.9 SLA, and that's inclusive of maintenance. Right? Just like with Cloud SQL, we take the same approach, right? So we apply the patches beforehand. But one difference is the instance, the patched instance is warmed up. So basically the cache is built up before we actually release the instance in production. The end result is that we can support a higher SLA than Cloud SQL, 4.9, as I mentioned to you, and that's inclusive of maintenance. But if you don't need that much scalability, if you don't need horizontal scalability, you don't need that much SLA, maybe AlloyDB might be a little bit overkill for your workload, and that's something we can help you decide if you're interested. The other thing is currently the maximum size you can have in AlloyDB is 16 terabytes. By year end is going to be 64 terabytes in size. And by the end of 2024, it's going to be 128 terabytes. So we're adding additional capacity slowly, just because we have to make sure it doesn't affect the rest of the instances, and we have to make sure we size up the instance, not only the instances, but the entire environment in conjunction with the additional capability that you can have. All right. Let me pause here for a second. Stacy, we have any questions on the chat?
Yes, we do. So we have Daniel was asking. So yes, AlloyDB's high performance database, as you mentioned. So all good. Is it better suited for transactional or analytical workloads, or both?
Right. Thank you, Daniel. So yes, like any other relational database, is better suited to relational workloads. But given improvements we made to AlloyDB, you can use it for analytical workloads as well. Now, let me be very clear about this. It's not intended to be your enterprise data warehouse solution. That's why we have BigQuery, which is something we're going to discuss in a moment. But sometimes you may have a relational database that you would like to run some analytical queries from time to time, and you don't want to create a pipeline to move your data from, say, Postgres or Cloud SQL to BigQuery. In those situations, AlloyDB might be perfectly fine. We would have to help you make that decision based on the requirements that you have for your analytical workloads. But the short answer is it's most likely possible to run your analytical workloads in AlloyDB. Don't use it as an enterprise data warehouse solution, talking about multiple terabytes of data, for example. That's not going to be possible for two reasons. First of all, we can't really have that much data in AlloyDB today. Not even by end of 2024. As I mentioned, it's going to be 128 terabytes in size. But also, it can't really scale up that much for analytical queries as BigQuery can do. But having said that, is a great fit for mixed workloads. Any other question, Stacy?
No, that was the for this slide. That was the only one.
All right, awesome. So next one is Cloud Spanner. Cloud Spanner is really a truly unique relational database solution. I'm going to ask you to draw your attention to the table on the bottom right. So that table summarizes the typical characteristics of a relational database and a non-relational database. So if you look at the middle column, a traditional relational database can support schemas or schema definition, right? So that's something you do beforehand, define your data model, your schemas, etc. It tends to support SQL statements and NC SQL statements as well. They may have something that's specific to the database engines, for example, like PG/SQL for Postgres or TSQL for SQL Server, but they all typically support SQL NC as well. And it has a strong consistency. That's the whole point of a relational database, to ensure data integrity, right? So therefore, consistency is key. It has to be strong, otherwise it does not qualify as a potential relational solution. On the other hand, and perhaps because of the limit, not the limitation, but the fact that it's highly It maintains integrity really well. It can only use certain specific features for availability. Usually, it's just on a failover kind of mechanism, right? So you have a primary instance and you have a failover, which is usually it might be a warm standby or it might be a cold standby. And if something happens to a primary, you have to failover, right? That's typically how it works. Um, and scalability tends to be only on the vertical side. So you can add more resources to it, more CPU, more memory, but you usually don't create a cluster or pool of resources the same way as you do with the NoSQL solutions. And by the way, for those who are thinking, oh, Oracle can do that with RAC, well, RAC can do that from a CPU and memory standpoint, but the storage is still shared across all the nodes. So it's not a truly horizontal scalable solution. The replication is configurable, right? It depends if you want to have asynchronous or synchronous, depending on the regions involved or the distance involved. Now, a traditional non-relational database, the column on the right, doesn't have anything that a relational database offers in terms of data integrity. So that basically means it's schemaless, which sometimes can be desirable depending on a specific workload. Usually does not support SQL statements. Some NoSQL databases have some SQL semantics, but they are typically very limited. And it's only eventual consistency. So if you have a cluster of resources with multiple nodes and you write to a given node, that transaction is not going to be necessarily visible to another node in the cluster. So that is really what the eventual consistency is. On the positive side, it's highly available, right? So you have multiple nodes in the same cluster working in parallel, and it's horizontally scalable. So you can add more nodes to your cluster and scale up the capacity from a parallel standpoint. Now, we don't like that, right? We want something that we could have all the properties of a traditional relational database solution, but also the benefits of a non-relational solution. And that's exactly what we've done with Cloud Spinner. So you might be asking, how is that possible? So that tends to basically violate the CAP theorem, right? So the reason why we can do that is because we deployed across all the regions on GCP atomic clocks. And those clocks are synchronized in real time in all regions. And we use the atomic clocks to basically have it as an external consistency method, right, to guarantee the serialization of transactions. The mechanism behind it is a little bit beyond the scope of this conversation, but we'll be more than happy to talk to you offline if you're interested. But the end result is we can offer all the relational properties of a database and still ensure that the database is horizontally scalable. It is high available because you have always a cluster of nodes. You don't have the concept of having one node or one instance for Cloud Spinner. When we talk about one instance for Cloud Spinner, we're talking about at least 3 nodes behind the scenes. And if you look at the screenshot on the top right, that represents really well what I'm talking about. So in that case, I have one instance of Spinner with 3 nodes, which is the smaller instance you can have. And all those nodes are basically stored in different zones. And if you look at the blocks, right, the blue blocks there, they represent data blocks. We have copies of those blocks across all the zones. And they are located in different locations or in different locations from a disk standpoint. So that allows Cloud Spinner to work in parallel and retrieve those splits based on the best location for that given workload. And the other thing is, if one zone fails completely, right, that's not a problem because we have a copy of the entire database in 2 other zones that can take over automatically. Now, going back to what Spanner is, it's a fully managed relational database solution, as I mentioned, and low ops, just like Cloud SQL and AlloyDB. Now, it is a truly cloud native solution. You won't be able to see a Cloud Spinner version for on-premise, for example. It is something we developed internally at Google, and it's been designed from get-go to work in the cloud. Now, one very important feature of Cloud Spanner, and that really is intended for mission-critical workloads, is how much SLA we can guarantee with Spanner. Given the fact that we can have so much parallelization with Cloud Spanner, and the fact that we can have multiple nodes working in the same cluster, in a multi-regional configuration, we can offer 5 nines SLA. That is pretty much unmatched in the market today. Though I really can't think of any vendor that can provide that much SLA, and that's guaranteed by contract. The other thing is, because the replication across all those zones is always going to be in real time, so it's synchronous. That guarantees a zero data loss. You simply don't have a data loss with Spanner. The only situation would have been if all the regions in the world and all the zones fail at the same time. So, but quite frankly, if that happens, that's the least of our problems, right? So that's something really massive that happened. In that case, of course, no solution would help you. But under normal circumstances, you simply don't see two failures in two regions at the same time and all the zones at the same time. That simply doesn't happen. And the other thing, there's no concept of RTO, right? All those nodes are working all the time in parallel. So you don't have, like, something happens to a zone, I have to fail over and bring up my instance and reconnect. No, that simply does not exist. If a zone fails, the other two zones will continue working for you automatically. You don't have to do anything about it. There's no downtime involved for any planned maintenance. We apply the patches in a rolling fashion, so that basically that basically means you don't experience any downtime whatsoever. And as I mentioned, you can scale up horizontally as needed. You can have virtually thousands of nodes working in parallel in the same cluster. The choice is yours. Now, when should I use it? The main use case is when I want a globally distributed database, a relational database. When I mean globally, I mean across multiple regions if you want. You can have Cloud Spanner spanning from North America to Europe, for example, which is something I've seen all the time with customers. Or you can have between Europe and Asia, or you can have multiple regions in North America. The choice is yours. The other use case is, given the fact that we can support such a high SLA, it is intended for highly or mission critical applications, or you really can't experience any downtime. You need the application to run 24/7. I absolutely cannot sustain a single second or a single minute of downtime. That is a perfect use case for Cloud Spanner. And you need to be able to scale up linearly and horizontally, which is an important aspect. So when you add another node to that cluster, you're adding more capacity in all three metrics, right? CPU, memory, and storage, or throughput. When you add more capacity to AlloyDB or Cloud SQL or any other relation database for that matter, you tend to increase capacity from a CPU memory standpoint, but not from an I/O throughput standpoint. Each Cloud Spanner node is self-sufficient from that point. That basically means if you add more nodes to your cluster, you're basically scaling up linearly. You're adding more capacity on all metrics. When should you not use Cloud Spanner? Well, if you need only 4 nines, Cloud Spanner might be overkill. In that case, I would recommend AlloyDB. You may not need the horizontal scalability of Cloud Spanner. In that case, a vertically scalable solution like AlloyDB or Cloud SQL might be a better fit for a lower cost. Or if you're using a lot of database-specific semantics like TSQL, PGSQL, that kind of stuff, all that code would have to be converted to SQL ANSI. So Cloud Spanner does support SQL statements. Of course, it's a relational database, but it does not support things such as TSQL, PGSQL, or PLSQL, or those specific database engine code, right? So they will have to be refactored. give me a second here. I'm just looking to see if there's anybody waiting for me for the room
Yeah,
here.
just time check. It's 1 p.m. So just to let you know where you are in your slide and where we are in the and Jimmy has a question at the same time. And yeah, I know you're in the Google room and I know how it works.
Yeah.
Somebody may come knocking. Said Jimmy was asking like any tips to further lower the cost for Spanner beyond regional on a like 3 years commitment.
No, you mentioned the biggest opportunity to save cost in Spanner is to use a regional deployment rather than a multi-regional. A multi-regional tends to be more expensive just because you have to replicate everything across multiple regions. So that's number one. Sometimes I've seen customers using a multi-regional configuration where they don't need that much scalability or availability. So that's the number one. The other option, the other way is, Julie, to have a look at your resource allocation in terms of number of nodes. I have seen customers, for example, that had to beef up their cluster sizes in terms of nodes because there are a few queries that are misbehaving. So we simply tune those queries. I think with just two or three, if I'm not mistaken, and CPU utilization and memory dropped significantly. At that point, they were able to reduce the number of nodes involved or allocated to the cluster. That's pretty much it. You don't have the concept of allocating CPUs and memory to Cloud Spanner, right? It's not really how it's designed. It's designed for horizontal scalability. That means you just add more nodes. So the best way is to minimize the workload requirements, and then you can scale down your cluster size. That's pretty. Any other questions, Stacy?
No, Jimmy is the thank you for the tip. So yeah, no, we're good.
All right. So bare metal solution, I'm going to talk very quickly about this. Oracle is a tricky database to modernize just because Oracle does not recognize cloud from a licensing standpoint. And it is tricky because some of the features you see in Oracle can't be replicated anywhere. So the way we've provided a solution for this is we created an environment called bare metal solution, which essentially is just a physical hardware that's specialized for Oracle workloads. That way you can lift and shift the Oracle database directly to the cloud. Those solutions, or the bare metal solution, typically sits closer to GCP data centers, guaranteeing a round trip latency of less than 2 milliseconds. So it's very fast. That way you can integrate with the application if you're using Oracle. So that is useful in scenarios where you have, for example, you have to exit the data center, right? So and you have a date by which you have to leave it, and you don't have time to refactor code and all that stuff. You simply wanted to move your Oracle workloads to something else. Or you have a legacy hardware that is going to be decommissioned and it wants to upgrade it. So in that case, yeah, just move your Oracle workloads to bare metal. That's simply it, right? It's a physical hardware designed for Oracle workloads. Now, in terms of non-relation databases, the first one I want to talk about is BigQuery. I think many of you are familiar with that. Is our enterprise data warehouse solution. Honestly, I can't think of any database out there that can match the performance of BigQuery for analytical workloads. I've seen multiple terabytes of databases sizes and workloads working BigQuery perfectly fine. It's scale. I'm getting. Sorry, I'll just leave it. I'm moving to a different room now. Just give me a sec. While we doing this, any questions, Stacy?
No, the rest is good. So we'll have a live tour of the Google office while you move on.
Yes. Yeah. So you're gonna get a free tour while I'm talking. Just need to find my other room. Yeah. Sometimes it's tricky to find rooms here just because there's so many people. Aha! I found
Okay.
my new room.
Okay. Perfect. Excellent.
All right. So sorry about that brief interruption, but I was saying about BigQuery is it is designed for relational workloads, for analytical workloads, and much more than what AlloyDB can do. It's really for multi-terabyte database sizes. 4 nines SLA, which is something you don't typically see with enterprise data houses. You usually see 3 SLAs. 4 nines SLA with BigQuery. of compute and storage, similar to what we've done with AlloyDB. As a matter of fact, BigQuery was the first one to introduce that. It supports 2011 ANSI SQL, right? So just because it's an enterprise or a house solution, it doesn't mean that you have to write specific queries for that. You can use it for you can use ANSI SQL inside BigQuery perfectly. Now, what's truly unique about BigQuery is the ability to write and use the engine for machine learning. So let's say you wanted to add some predictions here in the report, and you don't know anything about data science. You don't want to mess around with the TensorFlow or scikit-learn, or any of those libraries. What you can do is you simply write queries using SQL statements using BigQuery ML. It's very simple to use. I've done it a few times, and you can add predictive analytics to your workloads with just SQL statements. And we also support the ability to have your data on-premise, not on-premise, rather, on a different cloud, and have the BigQuery engine sitting on GCP. That's something we support as well. It's supported with the BigQuery Omni. So when should you use it? Well, the answer is simple. If you need a very fast analytical workload, analytical database that support a multi-terabyte database, that's the only one you're going to need. BigQuery is the solution for that. Now, BigQuery is serverless. You don't have to manage anything. There's no concept of instance in BigQuery. So the slide you see, the screenshot you see on the right, is basically what it is, right? Is you simply consume the service, you create the data sets and start loading the data and start using it. You don't have to create an instance or size the instance, any of that, right? It's serverless. You may want a cost-effective solution, storage solution specifically, maybe even for backups. I have customers using BigQuery as a backup mechanism for their relational databases. It's so inexpensive from a storage standpoint that it makes sense to use BigQuery in some cases to keep your database online and at the same time available for queries. So sometimes you use just GCS or any other storage solution to store your backups. But the advantage is you cannot query those tables, right? If you move to BigQuery, you can actually use it. You can use it as with the SQL statement and query the data if you need it. And of course, if you wanted to use machine learning in your queries, but you don't want to write code in Python or using scikit-learn or any of those libraries, BigQuery would be a good fit as well. Now, very important to keep in mind, because I've seen customers do that. BigQuery is not designed for relational workloads. It's designed for enterprise data warehouse analytical workloads. If you try to do role-based access with a lot of joins and lookups and that kind of stuff, BigQuery will struggle because it's not designed for that. Now, if you wanted to do that occasionally, that's perfectly fine. But if you try to use like BigQuery to write a cursor of, 200,000 records, it's not going to perform well because it's not designed for that. I only have 5 minutes left, so I'm just going to skip through this very quickly. So Bigtable is a NoSQL solution. If you think about HBase, that's pretty much what it is. It's designed for low latency, extreme low latency, I would say. If you have, for example, things such as sensor data that generates potentially gigabytes of data in a minute, or I've seen cases where terabytes of data can be generated in 1 hour. That is in case of jet engines, for example. It's going to be very difficult to find any database that can provide the low latency requirements for that amount of data ingestion. So Bigtable can do that, right? So it has a very low latency for data ingestion. It's used typically for sensors data, for things such as stock prices, where the prices multiple parts in less than 1 second. That is a perfect fit for that. Firestore is another NoSQL database, but it's differently than Bigtable, is a document-based database. That is a very interesting database for a few reasons, especially for development. It has an API that supports things such as real-time updates. So let's say, for example, we have an application, and the data in the backend gets refreshed or gets updated by another user. and you want to refresh that in the application. So the API would allow you to do it seamlessly. You don't have to write code for this, right? The API would provide that capability to refresh the data on the application side automatically. The other thing, it supports offline connectivity with the database. So that's very useful for mobile applications. You may have a client running with a mobile application and gets in the subway, lose connectivity, and the application crashes. So in the case of Firestore, that doesn't happen, right? The connectivity is lost, of course, but the application does not crash. The user can still use the application. And once the connectivity is reestablished, the data is going to be refreshed if needed. That happens automatically, and that is exposed through the API. Memory store is not really a database. It's a caching mechanism for databases. So that is used in scenarios where you have sub-millisecond latency requirements. In that case, what you can do is you put memory store in front of your backend. So your application hits memory store. If the data is in cache, great, it's going to retrieve the data from cache. Otherwise, it's going to go to the database, retrieve the data, and puts in cache for the next time. So that's essentially it. Doesn't add the persistence of a data storage, but it adds that caching mechanism that is sometimes critical for the application. So I apologize for going fast on those last three slides, but you're going to have access to those slides later on. You can have a look at the what we discussed and some other specifics that we haven't been able to cover. The last two things I want to talk about is how to move data, right? So DMS is the favorite choice when you have homogeneous migrations involved. So you may want to move from MySQL to Cloud SQL, for example. We do have a MySQL engine in Cloud SQL, or Postgres to Postgres. But we have actually, that was the original intention, right? Having a homogeneous migration mechanism. But now we are starting to offer things such as Oracle to Postgres. If you have a Oracle workload, it's in preview mode today, but it's going to be GA soon. You're going to be able to use DMS, database migration service, to move that data to Cloud SQL, for example, seamlessly. Data conversion and refactoring may happen in real time with minimal downtime. It's serverless. There's nothing to manage in terms of instances or anything like this. It scales up with the size of your workload. And the best of all is it doesn't cost anything. So if you need move data from existing relational databases to Cloud SQL, that is the choice. That is the best choice for you. Now, in some situations, you may have heterogeneous migrations to perform. So you wanted to move, for example, from Postgres to BigQuery. In that case, DMS is not going to help. But the solution for this is called DataStream. And DataStream provides exactly that capability, the ability to move things such as Postgres to BigQuery, or Oracle to Postgres, which can be done also with DMS, or Oracle to BigQuery or GCS. And we are expanding the sources and targets that are going to be supported by DataStream. Right? Today, we have limited capabilities in terms of what sources and targets, but that's expanding very quickly. And finally, the last slide is the partner solutions that we talked about. So all those solutions we talked so far are GCP native, or basically you go to the console and you have them available there. But if you have specific requirements for specific versions that we can support or database engines, you can always tap into the GCP marketplace and consume those resources, those services. The advantage of doing so is that you have only one company to deal with in terms of support, in terms of billing, and it's the same experience as everything else on GCP. So with that, we have 1 minute left for questions. Stacy, do we have any questions?
I have no new questions in the chat. I'm looking at the Q&A now. So Daniel and Jimmy were the one with questions. So yeah.
All right. So yeah, I apologize for going so quickly on the last few slides, but I just realized that I realized we were running out of time, so I had to almost skip through those. But probably that's the reason why I don't have questions. But feel free to reach out. We'll always be happy to answer your questions offline if needed.
No problem. They can play back the video at 0.5x, so it's slower. afterwards. It won't be a problem.
Yeah.
Excellent. Great. So I'll just, if you can just release the share, I'll hijack it back from you,
Yeah. Thank you.
and we'll yeah, just stop sharing in blue. You should be. Here we go. Oh, we have a question from Martin. Is DMS used to migrate to the solution we reviewed today?
Yeah, it's used a lot to migrate to Cloud SQL specifically. If you have things such as Postgres or Oracle or MySQL databases, and you want to move to Cloud SQL, and you don't want to do it offline, you want to do it in real time, DMS is perfect for that because it's going to allow you to do it. We actually going to provide SQL Server support as well very soon. And as I mentioned a few times, that we are actually expanding the number of sources and targets we're gonna offer in the future. But yes, so the short answer is yes.
That's good news. All right, so we are at we are at time, so I'm just gonna share the wrap up slide. So I wanted to thank everybody. Rogerio, big thank you. It seems the last time we saw each other at Google in Toronto, like just having coffee and say like, hey, it would be great to do a data event. Now we've done it, which is great, because I think it's something that we don't like. We're all usually like people love like, oh yeah, it's serverless, it's security, it's like CI/CD pipelines, but there's something we need to store the stuff somewhere, right? And it's usually I don't want to say it's overlooked, but we don't really focus on it as much as we should. And for everybody, again, like thank you, and I think it was a great overview of what we can do, in Google Cloud when it comes to getting our data stored in memory or distributed database or an atomic distributed database like Spanner. Um, so for everybody, this is well in the last months we've been quite busy with one event per month, with the summer actually being officially here because it's today, it's June 21st. So future event, so targeting September, this September, so maybe like I mentioned earlier on, like um a next 23 recap, so maybe at the Montreal office, maybe in hybrid mode, so we can still have people online if everybody fits in the same time zone. So and again, like if you want to submit talks, we always welcome people from the community to give us their stories. So even if it's not a 45-minute presentation where you want to give us like the TLDR, what you're doing in GCP, and it's 15 minutes or 20 minutes, more than happy to have you present. So just reach out. Would be nice to hear from your stories. We still have the Google Slack channel public there, so if you want to have a chat there, you can always join and ping us straight in Slack. And I just mentioned that, yeah, it's June 21st. So what we're coming in, like summer is finally here. Hopefully it's nice for everybody. Since this is GGG Cloud Montreal, so I wanna so this Friday everybody's gonna be off. Saturday is June 24th, so it is Saint Jean Baptiste. So Bon Saint Jean for all our for everybody in Quebec, and the next one coming for Bulgaria. So I don't want to leave you hanging. So July 1st you'll have Canada Day. So we'll also be off. So another day coming. So yeah, so great. Great off season, everybody, and we'll see you back. It's September. And we're gonna go. Thanks again for your time. It was awesome.
Thank you, folks. Appreciate being here.
All right. Thanks, everyone.
Bye bye.
Bye bye.